For thousands of years, humans found their way by looking to the sky. Sailors used the constellations, sun and moon to navigate to distant shores. Today, all that's needed is a device called a GPS receiver. GPS stands for Global Positioning System, and it lets us know where we are and where we are going anywhere on Earth. It is a system of 30 plus navigation satellites circling the Earth. We know where they are because they constantly send out signals. Initially, GPS was developed for military use, but currently anyone with a GPS receiver can receive radio signals from GPS satellites. Previously, there were 24 GPS satellites orbiting the Earth every 12 hours at a height of 20,180 kilometers. Later on, to improve location accuracy, the number of satellites were also increased to 32. It is no understatement calling this technology a miracle, a pocket-sized device that can pinpoint its location anywhere on Earth. It is the modern world's answer to the compass. Each satellite circles the globe at about 12,000 miles, that is 19,300 kilometers, every day. The paths of the satellites are programmed in such a way that there are at least 4 satellites visible in the sky at any given time and place on Earth. Each of these GPS satellites sends information about its position and the current time to the GPS receiver at fixed regular instants of time. This information is transmitted to the receiver in the form of signal, which is then intercepted by the receiver devices. These signals are radio signals that travel with the speed of light. The distance between a GPS receiver and the satellite is calculated by finding the difference between the time the signal was sent from GPS satellite and the time the GPS receiver received the signal. Once the receiver receives the signal from at least 3 satellites, the receiver then points its location using trilateration process. Well, trilateration process is the process of determining your position based on the intersection of its pairs. A GPS requires at least 3 satellites to calculate 2D position, that is latitude and longitude on a map. In this case, the GPS receiver assumes that it is located at mean sea level. However, it requires at least 4 satellites to find receiver's 3D position, that is latitude, longitude and altitude. Localization of any GPS receiver is done through time of flight measurement. The greater the number of satellites in line of sight to a GPS receiver, the greater is the accuracy in determining the position of the receiver. Today, with a GPS car tracking system, we are at a point where it's impossible to get lost. A GPS operates independently of the user's internet connection or telephone signal. However, their presence increases the effectiveness of GPS positioning. GPS satellites have atomic clocks on board to keep accurate time. General relativity predicts that time will appear to run slower on the stronger gravitational pull. The clocks on board the satellites will therefore seem to run faster than a clock on Earth. Furthermore, special relativity predicts that because the satellite's clocks are moving relative to a clock on Earth, they will appear to run slower. The whole GPS network has to make allowances for these effects. It's a proof that relativity has a real impact on this one.